Hello, Duke Squad. Have you ever wondered if a black hole could destroy the entire universe? Black holes can swallow stars, bend space and time, and trap even light itself. But could one black hole eventually consume the entire universe? Scientists have been studying this terrifying possibility for decades, and the answer is more fascinating than you think. Welcome to Duke's Science World, where science meets mystery. Black holes are one of the most mysterious objects ever discovered in space. They are invisible, unbelievably powerful, and capable of bending space and time itself. Some black holes are millions or even billions of times more massive than our Sun, and because of their terrifying power, many people wonder, could a black hole one day destroy the entire universe? To answer that question, we first need to understand how black holes actually work. A black hole is formed when a massive star reaches the end of its life. For millions of years, stars produce energy through nuclear fusion. This energy pushes outward while gravity pulls inward. As long as these two forces stay balanced, the star survives. But eventually the star runs out of fuel. When that happens, gravity wins. The star collapses violently under its own weight. In only a few seconds, the core becomes smaller and smaller until it is crushed into an incredibly tiny region with enormous density. This creates a black hole. Around every black hole is a boundary called the event horizon. Once anything crosses this boundary, escape becomes impossible. Not even light can escape its gravity. That is why black holes appear completely dark. Now here comes the frightening part. Black holes continue growing by absorbing matter around them. They can consume gas clouds, planets, moons, stars, and even other black holes. Some black holes become so massive that they are called supermassive black holes. Scientists believe nearly every large galaxy contains one. At the center of the Milky Way exists a supermassive black hole called Sagittarius, a star. It contains the mass of nearly 4 million suns. Hearing this, you might imagine black holes as giant cosmic vacuum cleaners pulling everything toward them. But that is not exactly true. Black holes obey the same laws of gravity as other objects in space. If our Sun were magically replaced by a black hole with the same mass, Earth would continue orbiting almost normally. We would freeze because sunlight disappears, but Earth would not suddenly fall into the black hole. This is because gravity depends mainly on mass and distance. Faraway objects are not automatically pulled into black holes. Only objects that come very close are in danger. So if black holes cannot instantly swallow everything nearby, could they slowly grow over time and eventually consume the entire universe? Probably not. The biggest reason is the size of the universe itself. The universe is unbelievably huge. Our galaxy alone contains hundreds of billions of stars. And beyond our galaxy are trillions of other galaxies spread across unimaginable distances. Even light, traveling at 300,000 kilometers per second, takes billions of years to cross certain parts of the universe. That means black holes are separated from most objects by enormous empty distances. But there is another important reason. The universe is expanding. Scientists discovered that galaxies are moving away from each other in almost every direction. And this expansion is actually accelerating. This means distant galaxies are becoming farther apart over time. So instead of black holes moving closer to consume everything, much of the universe is drifting farther away. Even the largest known black holes mainly affect their nearby surroundings. Their gravity becomes weaker with distance, just like the gravity of planets and stars. Still, black holes are incredibly dangerous on a local scale. If a star gets too close, the black hole's gravity stretches it apart in a process called spaghettification. The star is literally torn apart into streams of hot gas before being consumed. Scientists have actually observed stars being destroyed this way. As matter falls into a black hole, it heats up to millions of degrees and releases enormous amounts of radiation. But surprisingly, black holes may not live forever. In the 1970s, the famous physicist Stephen Hawking proposed a theory known as Hawking radiation. According to this theory, black holes slowly lose energy over extremely long periods of time. Tiny particles near the edge of the black hole can cause it to gradually shrink. Eventually, after unimaginable lengths of time, a black hole could completely disappear. For supermassive black holes, this process would take far longer than the current age of the universe. But according to modern physics, black holes are not eternal monsters. So, based on everything scientists understand today, a black hole destroying the entire universe is extremely unlikely. Black holes are powerful enough to destroy nearby stars, planets, and even solar systems. But the universe itself is simply too large, too spread out, and constantly expanding. Yet black holes remain one of the greatest unsolved mysteries in science. What truly exists inside them? Does the singularity break the laws of physics? Could black holes connect to other universes through wormholes? Nobody knows for sure. And that is what makes black holes so fascinating. They are not just cosmic destroyers. They may also hold the secrets of space, time, and the origins of the universe itself. What do you think? Could black holes hide something even stranger than we imagine? Comment your thoughts below. And subscribe to Duke's Science World for more science and space mysteries. The universe is filled with mysteries waiting to be discovered. Until the next mystery, this is Duke's Science World. See you later, Duke Squad.